for F5 DNS. And for those all of you who already have been working with F5, you can just bear with me for 5 to 10 minutes, since we have few of them here who are, they have no experience with F5. So I'll just start an introduction with F5, and then we will jump into the core part F5 DNS. Okay. All right. Yes. Yeah. So F5 DNS. This is where you're going here. F5 DNS course. Before I start speaking about the F5 DNS, first I just need to give you from my perspective, I just want to speak about the F5. What is F5 in an overall view? What is an F5? Okay, F5 is, guys, it's a vendor. F5 is a vendor which generates some solutions to optimize the application performance, to deliver the application, and to secure the application, right? So we have three concerns here. One is delivering the application. Now, what is this application? It can be whatever it is. It can be an HTTPS web service. It can be a file transfer, FTP, or FTPS, or SFTP. It can be a DNS, right? It can be a DHCP. Okay, whatever it is, all these are application layer protocols. So all the layer 7 protocols, whatever the applications you are running within your organization, delivering them is the most important factor, right? Guess what? We have multiple network vendors. We have Cisco, we have Juniper, we have Checkpoint, we have Palo Alto. All these are the network vendors, and the question raises is, are these vendors not delivering the application? Right? You will have a question. Yeah, I work for Cisco, and what is Cisco doing? Is it not delivering the application? Or Juniper, or HP, Dell, or you have multiple vendors. You have Barracuda, you have Checkpoint, you have Palo Alto, which are purely the security concern vendors. Are these not delivering the application? Means, I say no. Okay, these are delivering the network layer. These are delivering the above network layer, TCP layer, right? But they are not delivering the application. Now, what makes a difference is, let's say if you have a Cisco device in between, you have an end user accessing some application, web service, or FTP file transfer service, whatever it is, couple of applications, and he is accessing the application. The device in between, whatever it is, Cisco firewall, it could be Cisco device, it could be Juniper device, it could be network device, it could be router, switch, whatever it is. He, whatever the device in between, he is never checking the packet beyond layer 3, or in some cases beyond layer 4. He is not aware of that application traffic which is going through him. What all he concerned is, I see the layer 3, what is the destination IP address, I route the traffic. What is layer 4 information? In some cases, what is layer 4 information? Is this permitted? Route it. But What is at layer 7, he is never concerned. If there is a packet for him, then he is taking at layer 7, he is taking the SSH packet, he is taking the telnet packet, he is taking the HTTP packet, which are for him. But he is not expecting this level at that level, layer 7, for all the packets that are going through him. He never do that. Right? Hence, these are not delivering the application, these are not optimizing the application, these are not securing the applications. No, these are not such kind of devices, and hence these are called as network vendors. Okay, so what are the Cisco, Juniper, HP, Dell, whatever the vendors you have, what are the routers, what are the switches, what are the data center switches, whatever the firewalls we have, they are all the network related products. But when it comes to FI, it starts at layer 2, and normally in production you don't tell the FI box to look at layer 2, but obviously it has that capability to do that, but we never do that. And beyond layer 2, when a packet is going, FI can check and make decisions based on L3 IP address, based on L4 port numbers, and beyond layer 4 L7. That means if there is an HTTP packet going, FI device can check that HTTP header, HTTP data, and accordingly it can make a decision. Maybe it is switching, or maybe it is load balancing, or maybe it is optimizing, offloading, whatever it is. FI will be able to do that, but not all other vendors, that which we normally see in our day-to-day life, right? And that's the reason FI focus on applications. So it is delivering the applications, it is optimizing the performance of the application, it is securing the application, right? And here I'm speaking about the FI, guys. Now, I'm not getting into in detail how all these can be done, but normally I'm focusing on what is FI. So FI is completely focused on application. Now, whether it is delivering the application, whether it is optimizing the application, whether it is securing the application, FI is one of the major vendors in the market today who does all these things. Okay, now how does FI do that? That's again a different scenario. Now when it comes to delivering the application, your ADC comes into picture. FI ADC, which is LTM, Local Traffic Manager, FI LTM is to deliver, optimize, offload the application responsibilities from the application server to the FI box, and he will be taking care of whatever the extra layer of responsibilities that server has to take, that would be offloaded to the LTM. Okay, and he does load balancing, and he does rewriting of the content, and he does monitoring of the content. Right, so when an application response is going, your Cisco device has not got the capability to check the content, and if the content is wrong, your Cisco device cannot stop the traffic, because it's not a device, or it's not a vendor normally that which works at layer 7, but it's a vendor who work at layer 3 and layer 4. But FI is the vendor whose product is LTM, who does these layer 7 decisions. Rewrite, monitoring, offloading, SL offloading, load balancing, and making all these decisions at L7. Okay, so in order to do all these things, FI have got all logical modules, right? So FI is a vendor. Now, within FI, who does that is vendors. Sorry, modules. LTM is one module who has got some core responsibilities. DNS is also one of the modules of FI whose responsibility is overall completely different to that of LTM. ASM is another module whose responsibility is completely different to that of DNS and LTM, right? But all these can come together, or all they can come together and make sure that all these are achieved, delivering, optimizing, secure application delivery. Okay, so overall FI is application focused, not network focused. Okay, guys. So that's an FI. FI is a vendor, right? Now, what does it have to do with the DNS? What is a DNS? Though FI is the actual vendor, it has got some logical modules, right? From FI perspective, they call it as the logical modules, but from technology perspective, DNS, LTM, ASM, all these are complete different technical aspects brought up together and are called as modules. Okay, so DNS has got some complete technology, and whatever the related concerns that they have, they all put the solutions together and they call it as a DNS. And delivering of the application, load balancing, all these sort of concepts, technical aspects, they brought up together and they call it as LTM, which is in layman language, it is an ADC, which is application delivery controller. So LTM is an ADC, application delivery controller. The name itself, it says it controls how the application should be delivered, and the responsibility of LTM is to deliver the application in a controlled manner. And ASM is securing your application. So whatever the concepts that are needed in order to secure an application, they all the technical aspects, all the technical concepts, they bundled all together and they named it as an ASM. Right. So these are from business perspective. In order to use these modules, the business team has to license that product. Okay, but from technical, from a person who wants to pursue career in FI, for him these are the pure technologies. Okay, but overall FI call them as modules. These are the modules. DNS is one sort of module, LTM is one sort of module, ASM is one sort of module, where each module has got its own responsibilities. Okay. Any doubts, guys, so far? Any hurdles, or is there anything that you didn't get the point clearly? All clear, is it? All right. Kapil is okay. Neeraj? Okay. I don't see a response. Okay. All right. So here, when we need to speak about the DNS, and one of F5 LTM. So in order to make this point clear, how is the DNS different from LTM? Is that in a layman language perspective, we have two terms: SLB, GSLB. Now, SLB is service load balancing. GSLB is global service load balancing. Now, why did I bring up these terms in here is your LTM is an SLB product. I mean, the overall, what is LTM doing is, yeah, the name is ADC, but from the operations perspective, it is doing a service load balance. The primary responsibility of an ADC or LTM is SLB, service load balancing. Whereas DNS is GSLB, global service load balancing. Okay. Now, what makes a difference here? Very simple, guys. Service load balancing is when an application request came in for a specific application. So there is an application request came in to your data center. Maybe it is your US data center, and you're having your organizational proprietary applications running. And you have this application running on multiple servers, and now you want to deliver the application, optimize the application, and offload the responsibilities of the servers. So overall, you want to do some server-related operations. Your SLB does that, service load balancing. So when application request came in, your SLB receives it, and SLB or ADC receives it. It verifies the things, verifies the configuration, and if the request is matching the configuration, then accordingly it will load balance the application request. Right? For suppose you raised an HTTPS request. Overall, it's an HTTP request, but which is secure. Now, this application request would first hit your SLB, ADC, Application Delivery Controller, or in FI terms LTM. And behind the LTM, you will have a couple of servers who are running that application. So your LTM will make some load balancing decisions here. So it will make a decision like which server has to be picked to forward this request, and any read-write has to be done, any persistence have to be done, any caching have to be done, any offloading have to be done. All these would be done by the LTM, and it will forward the request to that load balanced server. Right? So you understand. So SLB is your SLB will load balance the service request, application request. Now whatever it can be, HTTPS, FTP, SSH, right? It's voice over IP, whatever it is, whatever the application it is. Your SLB will receive the actual application request, and it will load balance the service to backend servers, whatever it has. But when it comes to GSLB, global server service load balancing, your GSLB will load balance the traffic. Ultimately, your SLB, service load balancer, and your GSLB as well. Both are directly or indirectly making sure that the load of the application is not on a single server or not on a single data center, but they are making sure that, hey, yes, the load, whatever is being received, is equally distributed or distributed based on a policy. Okay, but the way they do is little different. So your SLB will always receive actual application request and it will load balance to the application servers. But a GSLB will actually receive the DNS request and it will load balance those DNS requests. Okay. So ultimately what it is doing is whatever the application request that would be received, it is intelligently load balancing between the data centers. Okay, so your ADC or your SLB will always load balance the application request among the application servers present in a single data center. This is one of your data centers, DC1, DC2, DC3, DC4. Now, in all these data centers, you are having your common application. Okay, maybe a website. Let me take a website, www.example.com. This is my website I'm running on all these data centers. If the application request came to this DC1, the LTM within this DC1 will receive the application request and load balance between the servers of the DC1. This is SLB. But a GSLB will load balance this request among the data centers. Right? So once the request came in, it will make sure that this request will go to DC1. If there is another request came in, it will make sure that this request will go to DC2. Another request came in, it will make sure that it will go to DC3. Another request came in, it will make sure it will go to DC4. Right? So this is GSLB. So it's the GSLB is load balancing your request, application traffic, not at the server level within a data center, but it is load balancing at high level between the data centers, from one data center to other data center. And that's where this is global.
Look, I hope this is the case when there are active data center, right? Not of the case of the DC in the air.
And now see, this the point I'm speaking here is one of the core responsibilities and the deployment scenarios of a F5 DNS, right? And yes, this scenario what I'm speaking is when it is an active data center scenarios. Okay, but beyond this GSLB, our F5 DNS have got many other responsibilities as well. Okay, I'll be coming to that point again. But at this moment, you need to understand why, because if you have done your F5 DNS, the primary thing that you have to understand is what's the difference between an SLB and a GSLB. So SLB is load balancing the application request between the application servers, but GSLB is load balancing the application request between multiple data centers. Right? Any doubts in this concept is SLB versus GSLB? How it is load balancing between different data centers? I'll be coming to that point. But at this moment, you have to understand what's the difference between SLB and GSLB. So can I take it as no doubts? Kapil and Neeraj, no doubts? Okay, so you have something here. And see, now again, I did come to this point yet, GTM. I just only covered the what is SLB versus GSLB. Once you understand this, then I can clearly explain you what is GTM. We have not gone to GTM yet. Okay? Okay, so could you please repeat it again? Yeah, it's very simple. SLB is always load balancing the request within a data center. Okay, so your SLB, your service load balancing is load balancing your service, your application service, HTTP service, FTP service between HTTP servers, FTP servers. But GSLB is whatever the application it is, load balancing between global data centers. It's ideally load balancing, but not at server level, but it is load balancing at a data center level. Okay. Now again, within your each data center, you will have your ADCs, and this ADC will receive that request, and it will load balance again. It does the load balancing at server level. The ADC will be received, and it will load balance at server level. There will be a request coming to this data center, which was routed by the GSLB, that will be received by the ADC within that data center, and it will load balance it among the servers. Now this ADC is doing the SLB, server load balancing, and the GSLB is doing the global service load balancing. So first your load balancing starts at GSLB, and then it goes to your SLB device, and your SLB will load balance at server level. Okay. Yes, it is. That's yeah. That's where you will get your DNS into picture. That's where you get your GSLB concept in your environment. You should have the same application running on all your data centers. If you are running the same application on all the data centers, then only you would be performing the GSLB, global service load balancing. If you are running different applications at the different data centers, then there is no purpose of GSLB. You only do the SLB, server load balancing. So deployment is active or active standby in production. Now you can do it active, or you can go for active standby as well. You can do that. Okay, it's all your business requirement. How is your business demand is? Okay, for example, let me tell you, you have a couple of servers, applications running your within your actual data center, within your primary data center. You have your DRDC as well, disaster recovery DC as well. You are running same applications on your DRDC as well, right? On top of these data centers, you will be having an GSLB. So request will be received. At this moment, your DC is active. Your actual primary data center is active. So your GSLB will forward the traffic to primary data center. Okay. Now this is only the active. Now your DRDC is standby. It's not doing anything. It's a standby unit. Now let's say your DC have gone down. Connectivity to your data center, or you might be doing a DR activity. Okay. You might be testing your DR data center. So your DC went under maintenance. So you shut this everything, and you'll tell your GSLB to forward the traffic to DRDC. Then this becomes active and your primary data center goes standby. So you are running the same application, but the scenario here is active standby. Okay, you can go with active or you can go with active standby as well. That's your business requirement, how your business team or how does your IT architect would define. Accordingly you would use this GSLB. But yes, your GSLB is capable of doing both active or active standby, whatever it is. Okay, NetMinion. All right. So SLB is load balancing at server level. Actual application request will be received and load balanced at server level. And your LTM is your SLB. Right? You have an idea about LTM. So your LTM is doing the server load balance. Now GSLB is load balancing the request application traffic at multiple data centers globally. You have your application running globally on all multiple data centers, and you wanted to do some global server load balancing, not at a server level. Then you will have GSLB. Okay. Now, when it comes to F5 DNS, now you understood that yes, somewhere your F5 DNS is doing the GSLB. Okay, so your F5 DNS is a product who does GSLB, and your F5 LTM is a product who does SLB. Okay, now he is doing GSLB. Great, but why do we have a DNS concept here? What's the relation between GSLB and the DNS? Okay, so before I just go on to this, formally actually it was GTM, and now it is F5 DNS. LTM is local traffic manager who manages the traffic locally for a data center. GTM, global traffic manager. So whatever the traffic is received, your GTM will make sure that this is globally managed. Right, so now globally means you have multiple data centers, so it is load balancing between multiple data centers. Right? Great, the GTM was very good. Then why is the DNS came in? Yes, GTM was doing the global load balancing, but in order to do that global load balancing, the concept they dependent on was DNS. Okay, let me tell you, what is your LTM doing when a request came in? When a request came in, your LTM will check the virtual server. What is virtual server? So you will be defining an IP plus port, and once it is matching the virtual server, it will check for the bind pool. Whatever the pool is, what is actually bound with this virtual server that is taken. I mean, what pool is attached, that is picked up, and as per the pool, what is the algorithm defined? Now, within the load balancing, within the pool, you will be having a load balancing algorithm. You will define an algorithm, right? It uses this algorithm and it will pick one server among multiple application servers you have. So based on this algorithm, it is deciding who should this go to. It will pick one server and it will forward the request. Right? So your LTM is considering this algorithm, and it is also considering the application request. What is the request? What is HTTP request? If you have done some advanced LTM concepts, then it will be making decision based on the request also, right? So ultimately, in order to do the load balancing, LTM is considering the algorithm, and it is considering the configuration that you did, right? But when it comes to GTM or your DNS, FIDNS, first your request will hit your DNS. And guess what? What request is received? This is not your actual HTTP request, but it is your DNS request. Your client will first initiate a DNS request. So that DNS request is received by your DNS, and it will respond back with an IP address. Now, what are the IP address he gives? The client will go to that actual IP address, who is your LTM. Right? So the actual load balancing is happening based on the DNS. Hence, the name is DNS. So ultimately, your DNS is doing the FIDNS is doing the global load balancing, but it is using the fact DNS in order to do the global service load balancing, and that's the reason it is FIDNS. Okay. Just a second. Alright, yeah. So in order to make you understand this, I got some scenario here. So this is the scenario. I mean, how your global service load balancing happens. Okay, and in production, normally, what is your client doing, and how is that request coming to your LTM, and how is your LTM load balancing, and how it is going back. So from the scratch, from the very beginning of the request to the response, what is happening, and what is the role of DNS, FIDNS in that. Once I finish the scenario, you will be clearly understanding what is the purpose of FIDNS here. Okay, so normally, let me tell you, at this moment, I'll consider that there is no DNS in your production. You don't have FIDNS. And you are running something called example.com, www.example.com. So you're running on all these data centers. Now, within all these data centers, all these servers, pool of servers are running this application, example.com. Now, this client wants to access the example.com. What normally happens? This first client, in order to initiate this request to example.com, first he needs an IP address. Of what? Of example.com. See guys, example.com is the name used by humans in order to, since we are not good with numbers, we cannot remember IP addresses that great. So in order to resolve this issue, so we came up with the domain names. So domain names are very easy for us to remember, right? But again, when it comes back to the machines, they don't understand the domain names. They only understand numbers, IP addresses. So in order to make this thing simple, we have DNS. So you remember example.com, since you have some work to do, you need some transaction to be done in example.com. So you straight away went to your client, went to his browser, and it's in the browser, he entered www.example.com. But when it is done, this machine doesn't understand these domain names, right? So he now wants to resolve this example.com. He wants to get an IP address. He wants to know what is the IP address of this example.com, so that he will encapsulate his source IP. He will encapsulate the destination IP of the server, and he will forward the packet, and that will be routed by internet, and that will go to your example.com server. So this destination IP he needs, but he cannot keep all this example.com within the destination IP, right? He needs a particular IP address. So for that, he's in need of IP address. So before he actually initiates the HTTP request or S request, he will do a DNS request. So he will have a local DNS server defined on his computer. So his computer will initiate a request to the local DNS. So this client is asking this DNS, I want to speak to example.com, but I don't know what is the IP address of example.com. Since you are the DNS server, you might be having a answer for this. Can you please give me the IP address of example.com? This is a request sent by the client to the LDNS. Now you remember your LDNS will never have all the DNS entries within. Okay. After all, this is a server which is provided by your service provider, or this is something that you have. I mean, if you are having some business, then you would have your own DNS server. So this is some server organized by you, or for those who cannot organize for themselves, service provider will provide the service as LDNS, local DNS. So this client will initiate a request to this LDNS. It's very simple. He is asking IP address of example.com. So this LDNS, if he has an response, the IP address entry, he will straight away give it. Okay, take this. This is the IP address of example.com. Once the client gets the IP address, he will encapsulate source, destination, and he will forward the packet directly to the example.com. But if he don't have it, if the LDNS don't have it, he will keep the client on hold. And on behalf of this client, the LDNS will start resolving the name to an IP address. So it's all your LDNS responsibility to do the resolution process. So how does the resolution process go? Before initiating the process, your LDNS will check the query. This is for example.com. Now remember, I placed a dot here. Now when you are entering this URL, domain name within your browser, you might have entered it, this dot, or you might not have entered it. It doesn't matter, but when it comes for an LDNS, this dot is very important. Okay, and the resolution process, always remember your resolution process starts from your right to left. Okay, so yeah, it's for me right, and it's also right for you as well. So it's from your right to left. Resolution process will always do in this way. So what this LDNS will do is, he will example.com. Now what he does is, he will insert a dot here himself, the LDNS. He will consider a dot, whether you have entered it or you have not entered it. He will consider a dot here. And this dot is very important. This dot means root DNS. So this LDNS will have the IP address of this root DNS with him. Okay, your LDNS will always have the root DNS IP address with him. Okay, if it is your service provider will have that set configured on his LDNS, that who is a root DNS. So now what this DNS will do is, he will copy your request from the client. He'll copy this, and he will forward this request to root DNS. So LDNS will forward it to root DNS. Your root DNS will check it. Okay, this is for example.com, www.example.com. Your root DNS, if he has IP address, he will straight away give it, but in 99.99 scenarios, your root DNS will not have the IP addresses for domains. Okay? What are the things that it has is, it will have the IP addresses for top level DNS. Okay? Now, what are top level DNS? For example, let me write it here. www.example.com. This is your domain. Let me just go down. Okay. Let's say you have gone for Amazon.com. You have Amazon.com. You have Amazon.in as well. Right? If you are going for UK, Amazon.uk. If you are going for Canada, it might be something like this, Amazon.ca, Canada. Okay? This .com, this .in, this .uk, .ca, and another one as well, www.amazon.net. You will also see .net more nowadays. .net, right? .net. From the left, dot is your root DNS. .com, .in, .uk, .ca, .net. These are top level DNS. ELD, top level DNS servers. So the root DNS